All right. Hi, Raffi.
Hey Ron, how are you?
Good. How are you?
Doing
So,
well.
yeah, thank you for joining the mock interview. So, let's get started. All right. Good. So, the first question I have is, can you share a project that you have done and you are most proud of?
Yeah, I would say my last project for the Immersive was something that I was really proud of. So, what I did is I built two web scraping bots to crawl my Instagram network. And
Mm-hmm.
I performed graph theory and machine learning to better understand that network. Um, at first, I crawled all of my followers and their followers and created a interactive graph that showed all of the connections between the different communities of people in my network. And it was a really nice visualization to show how the groups were clustered. I used two clustering algorithms, the Louvain method and the Gervin-Newman method, to break down my friends into different categories. And it was just really cool to see. And from that next point, I thought it would be really cool to um, predict the engagement
Mm-hmm.
on a user's post. So I scraped the 12 most recent posts from all of my followers and took the images and the text and performed different machine learning methods to try to do that. And it was really difficult to do that because people post a wide variety of pictures. Um, but I found that combining the pictures with the text data and with tabular data, and then using some transfer learning, using a model from Google called NEMA to measure aesthetics of the picture quality, is actually able to get a really good score, error loss on my algorithm. So it was a lot of fun, and I found some really interesting things from that process.
I see. So, what does this score represent? Like, what are you trying to predict, or you are trying to generate some content?
Yeah, so at first I approached it as a classification problem, and I broke down the like and comment ratio into four different categories from high to low, and I found that that was really difficult to do. So then I pivoted and turned it into a regression problem where I was actually trying to predict the actual score, the engagement level on the post. So the error was the difference between my prediction and the actual likes and comment counts.
I see. Yeah, that sounds good. That's
Yeah.
very interesting. Yeah, it involves like several different kinds of machine learning algorithms, and I think transfer learning is also, I would say, the frontier of research. And you used pre-built model from Google. That's definitely, yeah, a very nice point. Good. So my next question is about your statistics knowledge. So how do you explain hypothesis testing to someone who is not familiar with statistics?
Yeah. So I would say hypothesis testing is a great way to determine whether or not your prior beliefs of something are true. So there are multiple steps to the hypothesis testing process. So first, you would state your question and create a null hypothesis, the original hypothesis that said, oh, A is not better than B. And then you would take a skeptic stance and choose the alternate and create an alternate hypothesis. From that moment, then you create a model to test whether or not that's true by using a threshold value and calculating the difference of the populations in each of those two categories.
Hmm, okay. So how would you explain p-value then?
Yeah, the p-value is the probability of seeing a result that is equal or greater than what you expected. And so if your p-value is greater than the threshold, you accept the null hypothesis, but if it's lower, then you reject the null hypothesis.
So is p-value the probability that you are going to, how to say, let me say it this way. So when we talk about the p-value, do we assume the null hypothesis being true or not?
We assume that it's being true.
Then we talk about the p-value, right? Yeah, good. All right. So my next question is about machine learning. So let's say I'm a beginner in machine learning and I'm confused with the k-means and the k-nearest neighbor algorithm. Their names look similar and they also contain nearest and mean, so I'm confused. How would you clarify the differences between these two algorithms?
Well, k-nearest neighbors is a clustering algorithm, and k-means, I believe, is also an unsupervised clustering algorithm, but I'm not so sure I can explain the differences between the two offhand. I think I would have to do a little Google searching to provide.
That's fine. So I will just ask questions so you can just answer. Like let's do this way. So which one is a supervised machine learning algorithm? Which one is not supervised? Which one is unsupervised?
Yeah, I believe k-nearest neighbors is supervised and k-means is unsupervised, which means that with the unsupervised k-means, you don't have a specific set of labels that you're trying to predict or classify within two. You're letting the computer find the relationship in the data itself.
Okay. So can you then explain the meaning of k in both algorithms? What's the meaning of k in k-nearest neighbor?
Ooh, I'm not so sure. I'd have to revisit that, the acronym.
Okay, yeah, I'll give you 30 seconds to do some quick Googling.
Okay. Okay, that's right. So K is the number of groups that you're looking to classify into. I think for both k-means and k-nearest neighbors.
So for k-nearest neighbor, what if I want to do binary classification? And can I choose k equal to 5 if I want to do binary classification?
No, in that case, you would choose, I believe, k equals 2 for either one or the other groupings.
Then how many neighbors do I choose to do the classification?
Maybe it would be 1 then, because you have one grouping and then you have the other grouping. So I guess you would only have one neighbor.
But but you said okay. So is k always 1?
No, it can be whatever you want it to be. You can choose the groupings that way.
Okay. I need to double check this, but I think I think the k here is the number of nearest neighbors you are looking at. Yeah. So let's say, because here is a classical problem. If k is the number of classes you want to how to say, you want to apply, you want to use in your algorithm, then it means the name of the algorithm need to change because it depends on the data set. But the naming, for example, a naming of algorithm shouldn't depend on the data set you actually want to use on, right? It sounds really weird. So the k here for the k, you're right for the k-means, but the k-means, because it's unsupervised and we don't know how many classes, how many clusters you're going to have, and you just set k as a hyperparameter. It's unsupervised. But for the k nearest neighbor, the k is the number of neighbors you will be looking at in order to determine the classification or the label of one specific data point.
Got it.
Yeah, that makes more sense. And the k is better to be an odd number, because if you got even like a volts, three, for example, you choose k equal to 4, and the 2 points side, okay, it's going to be an A, and another 2 points side, it's going to be a B, then you have a draw, so you don't know how to decide, right? Yeah. All right, so last question. So do you understand the picture of k nearest neighbor now?
Somewhat, yeah.
Somewhat, okay, good. So let's talk about the bias and the variance. So if k is so large that k is the size of your data set, so what will happen?
As it relates to bias and variance?
You can just answer the question directly, and then we will talk about the bias and variance later. Yeah.
Each node or each row of the data would be classified in its own bucket.
What's the definition of bucket here?
Like the community or cluster or grouping. So each grouping would just have one.
Yeah, just one, because we mentioned, like, we set k equal to the number of the data set, and the data set is fixed. So everybody is the new data points nearest neighbor, because they're at most k. So all data will be classified as the one single label, which is the majority of the data set.
Mm-hmm.
Yeah, so that makes sense. And what if k is very small? As you said, if you choose k equal to 1, then from k equal to the number of data set to the k equal to number k equal to 1, are we improving the model? Are we increasing the model's variance or not?
I believe you would be, increasing the model's variance.
Because
let me see, let me just try to remind myself. So bias and variance. So bias is when you are overtraining on, or you've overtrained on the data. And so when your model sees new data, it doesn't predict as well because it overfits to it. And variance is the opposite of that, but for some reason I'm blanking on the
other way around.
Oh, I always get them mixed up.
Yeah, that's fine. So you can, what I try to memorize is to think about variance as the complexity of the model on the training data. So if we are not doing like a testing or validation purely on available training data, the more complicated your model is, like you can say the model has higher variance. So if everything, like if k equal to the number of the data set, number of data points in the training data set, then your prediction will be like a single label. You just predict the majority of the training data set. Mm-hmm. But if you set k equal to 1, it means like your model will be very complicated. There are small regions like around each data point. Like if you are closing to that, then you are going to you're going to be labeled according to that neighbor. Then your whole feature space will be partitioned into small regions, like very small regions here and there. Then it's going to be complicated. Mm-hmm. So we say it's high variance. Yeah.
Got it.
Yeah. So you get it right. You got the idea right, but you may not be able to articulate it fluently. That's fine.
Yeah. Definitely need a little bit more practice.
Yeah. Practice is under pressure. Okay. Good. So let's move on to the SQL questions. So I believe you already opened the two questions I sent to you at the beginning of the interview, so you can open them and share your screen.
Okay.
Mm-hmm.
Is this the correct link?
I think it is. There is another one, right? I sent you two in Zoom.
Where's the chat?
I can send you again.
This is the first one, and then
Yeah, this is the first one.
the second one is right here.
Yes. Yeah, let's do the first one.
Okay. Okay. Let's see, I haven't used this. So, okay, I'm writing it down here. Query the count number of cities in city having population larger than 100,000.
Yeah.
Okay.
So let's change the engine from Oracle to the MySQL. So in Oracle, sometimes I have difficulty with the syntax, not syntax, with some function which should work, but it doesn't. So let's just switch to MySQL for safety.
Great. Okay. So I'm going to count all from city where population is larger than 100,000. I think that should do it.
And run code. Yeah, it's probably the comma. Yeah. Good, good. Okay, so let's add more flavor on that.
Okay.
So how about, I want to see the number of cities and grouped by district.
Okay. So we're gonna add district in here.
Yeah.
From city, population is greater than 100,000. And then we're gonna group by district. And I think that should do it.
Yeah, that's good because you, the wrong answer means you didn't reproduce the value of 6, so that's fine.
Oh, yep.
Good. Let's move on to next one.
Okay. The average population question?
Yep. Yes.
Great. Okay, given the city and country tables, query the names of all continents, the respective average city population, rounded down to the nearest integer. So
yeah, you can forget about the rounding part. Let's just get the logic correct. Yeah.
So it is, so we're getting the names of the continents, which is in the country table.
Yeah.
And their average city populations. Okay. So let's see. It looks like there's country code here.
Yeah.
And I'm guessing code here is probably the country code as well. So that's the primary.
Yeah, you don't need to guess. I think there is a small line mentioning that they are the keys. Note.
So country code and code are matching key columns.
Yeah.
So I think what we need to do is, so we'll select name of all the continents. name or continent, maybe continent. Yeah. It's like continent from country. And then
so they are all capitalized. To clarify it, let's use the dot. You can select country dot continent. So this way it's easier to you know, to see which is a column name, which is a table name.
Yep.
It's much cleaner to see.
Yep. So we're going to select the continent, and then from country, and then we are, let's see here. We can do like a sub query where we can first aggregate this information by the country code and get the average population. I guess we could do.
So to clarify your thinking process, so you want to build a table which contains the information of average population, average city population per country. Then you are going to join the two tables according to the continent.
Okay.
Is this what I'm like? What you are thinking?
Yeah, I think that's the way I would do it. So maybe I start with aggregating the city table, make sure I have that right, and then we can join it.
So can you join directly?
Yeah, I could actually join in. I could just do it on the city table and then join on the country code and then just pull in the continent that way.
Okay, yeah. I see a slightly like a direct approach, but we can go. Like I think your thinking process is fine. It's going to work. Yeah. So my impression is that since you want to connect these three objects or concepts, continent, country, and city, how about you join the two tables directly, like such that you can group by the continent directly. Like you can bypassing the country, like the relationship of country just by joining them.
Okay, well, yeah, we can do that.
You can avoid a subquery.
Yep. So we're going to join city on country code equals city country code. Yep. And then we are going to pull in the average city population, and then we're going to group by country, continent, by and then we're going to order by this. I think that should do it.
Yeah, it's changed the Oracle to MySQL as well. You see the drawing is not highlighted. That's really weird. Oh, you can change it back and copy it here.
Oh, nice. Okay. Thought that was going to happen.
Okay, let's try.
Okay.
It's probably because of the rounding. Yeah, probably because of the rounding. Yeah. Okay. Yeah, I think it's good. It should be the correct answer. Yeah.
To round it, would I just do round and then I would put in something like that? Oh, that's taking a long time. Still the wrong answer, but rounding worked.
Average population of each continent.
Just make sure.
Let's double check the question.
Average city populations rounded down to the nearest integer.
So can you remove the order by? Because this is not required in the the question. No. That's tricky.
Country, continent.
Okay, is it possible that because the join, no, not possible.
So the order of operations, does the join occur first before the select? I'm kind of blanking there because maybe it's, I wonder if we have to aggregate it first and then pull it in.
No, I don't think so. I think this is the correct logic.
Maybe it's not rounding down.
Yeah, so HackerRank has this long-standing issue of not clarifying with the actual like rounding down or rounding up. So you can check the editorial, but to check which problem exactly is here. But I think your logic is correct. Then I'm happy with this result. Yeah.
Right.
Yeah. Good. Yeah. You can stop sharing. Good. So that's the technical part. So do you have questions for me regarding today's questions or anything? Yeah, anything else?
I think besides just needing to review k-means and k-nearest neighbors, I think I'm okay. I definitely liked working with HackerRank. I thought that was pretty fun.
Yeah, and there are also machine learning questions there. It's not advertisement for them. They're just doing good job.
Great.
Yeah. All right. So I'll stop recording now.